Hey Alex, is it Alex or any
Yes,
other name?
yeah, my name is Alex. Hi everyone. Uh, my name is Alex. I live uh, in Charlotte, uh, in the States, and I currently work as I work in the IT field as an operations engineer. And yeah, that's a brief introduction from my side.
Thank you. So, are you working on IT and what is your role, current role?
I work as an operations engineer.
Okay.
Uh,
And Srinivas, about yourself?
Hey, hi. Yeah, currently I'm working as an IT. I'm working in IT industry from past 15 years, and I'm working as a data engineer, so lead data engineer, but not into AWS. I'm into Snowflake and PySpark and Python.
That's great. So, since how long you are in this domain?
Last 15 years,
Great.
I started my career with um, Informatica, and then I move on to next uh, uh, ETL, like a PL SQL developer, and then after that, then Medallion, Teradata developer. So
Wow.
then, yeah, Snowflake. So basically, I'm into this in line with the data engineering role, but with the different technologies I was working before.
Okay. That's really great because as you are a background completely into the data field, so it's very easy to understand you the concepts what we are going to discuss.
Yeah, yeah. I think so, hopefully.
Yeah.
But yeah, I'm new to this AWS services. I have a bit knowledge in Azure, but no idea about AWS. So I'm just uh, want to learning into AWS side.
Okay. Yeah. Can you please tell about yourself, Amarnath?
Hello, Harsha, now I'm in officers. Yeah. Like, hello, am I audible?
Yeah, please. Please go. Yeah, yeah.
Now I'm in officers. Yeah. I didn't talk.
Oh, okay, fine.
Okay.
So you are from which location?
I'm from Karnal, but I'm currently working in Paxit company.
Oh, okay, fine. Then.
Yeah.
Srinivas, you are from?
So I'm from USA.
Okay. Alex, yourself?
yes, I live in Charlotte in USA.
Okay, fine. Surya, please tell about yourself.
Sir, hi sir. My name is Surya. I'm from Karnool. My background is MBA. I'm now currently working in transport. Sir.
Okay,
No any background in IT field.
nice.
Okay, sir.
Thank you.
Okay, sir.
Yeah, about myself, I am Mr. Malik. I have 20 plus years of experience in IT in different technologies. Started with Oracle, SQL Server, and then PostgreSQL, and then Informatica, and then Cognos. I involved in different roles. Like I started with my career with a database developer. Then I moved to data warehouse consultant, and then Right now, I am working as a senior data analyst as well as the data engineer, senior data engineer. Because in companies, the designations may differ, but the role is different. So that's why this is the senior data analyst is my role right now. And then I have done my certifications in different technologies, SQL Server, Microsoft certified SQL Server, and Oracle certified DBA, as well as the developer, as well as the Linux certified, that is. And also Azure Data Engineer, I am certified Microsoft Azure Data Engineer. And also I'm trying to finish that, Amazon Data Analytics. And you know already that they have introduced a new certification this next month, actually, going to start that. That is a AWS Data Engineer. It's a new beta version of that certification. So it's a very, it has the current technologies as well as updated technologies. Okay, so that's about myself. And coming to the today's session, actually, the agenda of today is about what is data engineering and how it is evolved. What is data engineer's role in IT industry and skills required to become a data engineer, job opportunities, the future opportunities, and how it is implemented in different cloud platforms, and how what is in our curriculum in AWS data engineering. Okay, you might be coming from different backgrounds, like you may be coming from different non-IT or IT, or some fresh graduates also. But it is not a problem to switch your career from whatever the field you have right now, but you need to know a little bit about the main two important things is required to become a data engineer. That is, the first one is SQL. Basically, it is an underrated technology previously, but nowadays people are using it in different domains. So SQL is a 80%. We need to know about the SQL. That is not a programming language. Basically, it is a structured query language which contains some SQL commands, and it can be a data definition language, a data manipulation language, a data control language, a transaction control language. These are different, small English like keywords to get the data from database. Okay, so that is a must for any data engineer. And a programming language. A programming language in the sense it might not be a C++ or any complex language. As you know, the popular language is Python nowadays. Python is a simple English language. You need not to, write, or you not to write any complex programming, because as the libraries are available, developed by different people, just we need to import them and use them as per our needs in our business scenarios, only for scripting purpose, just for integration purposes. Okay, just you need to know about some of the libraries in Python. So these are the two important languages you need to know to become a data engineer. And one more thing is, one second, I'm just actually, what is data engineering role? It is in high demand in different organizations, and it is increasing as the data is data driven decision making, and it needs to manage different different data by these professionals to process and transform that data. Okay, as a data engineer, the primary role involves designing, building, and maintaining data pipelines. Okay, see, if you know one technology, not any one technology, the basic concept, the foundation of what is data and what is a distributed database system and what is distributed processing. Just one concept, one foundation. It may be a Hadoop, or it may be OpenStack technology, or it may be in Azure or a GCP, or Google Cloud, or in AWS. All the process is same. You need to know one technology, so that you have chosen this AWS data engineering. As you know that AWS is a popular technology, and it is the first started cloud platform, and it has so many, uh, you know, around 200 plus tools are there. But we need not to bother about all those tools. We just need to learn about our data and data engineering tasks. Okay. And to become a data engineer, you need to know little bit a combination of technical skills as well as some knowledge in data related technologies and tools. Okay, as I told you, you need to know SQL and one programming language, that may be a Java or Python. So Java is a little bit complex. So Python, in our curriculum, I am going to teach you about Python. Maybe you need not, you may not receive that syllabus, but I am going to teach you about Python programming language, the core concepts, and also SQL. Okay. And the second thing you need to know is about data warehousing. Understanding the data warehousing concepts, and what is dimensional modeling, and what is data modeling, and what is the difference between the online transaction processing and the analytical processing. That I am going to explain in depth concepts. Okay, you need not to worry about them. So you need to learn about data warehousing concepts. And then you need to know the third one is ETL, extract, transform and load. So this is the actually ability to design and implement ETL process to move the data or transform from various sources to data warehouses using the tools like, when you go to the OpenStack, Apache Spark, and different ETL tools are there like Talent. And data warehousing tools, when we coming to this our session, our curriculum, we are going to learn about Amazon Redshift. And there are different other platforms also, Google BigQuery and our Snowflake. These are the data warehousing tools. And ETL tools are Apache Spark or Talent. Okay. And the fourth one is data management system. You need to know about the relational database systems like MySQL, when you come to this relational databases, and when you go to this NoSQL databases like MongoDB or Cassandra. So a little bit about these data management systems. And you need to know about the big data technologies, because as the data is grown, we need to store the data, historical data, in the big databases. So in a different processing is also different here. Distributed processing, that is a distributed data processing. So we used to have, you need to learn about Hadoop system. You need not to know in-depth concepts about that, like how to install the Hadoop and how to configure it and how to access it and how to write code. These are not required. Just you need to know about the basic concepts about what is the Hadoop architecture and how it works with the HDFS file systems. Okay, this is the fifth one. And the sixth one is You need to know about, as I told you, data modeling. Understanding the data modeling concepts and like what is a data model and how to design the data using some ERD diagrams. Okay, and you need to know about to maintain all this code or your complete system. We need to have a version control. That is nothing but Git or GitHub. So we are going to learn about that one also, and also some automation tools like scripting and automation tools to maintain our pipelines or workflows. And when we come to our curriculum, that is AWS tools for data engineering, so we are going to learn about the different tools like S3, EC2, okay, Glue, and Redshift, and different tools. Okay, now a brief history about data. See, in the the world, in the old human civilization, they used to maintain the data in the form of you know uh, some kind of they are storing the data to keep that to keep track of their trade goods and tax rates and crop yields. For that, they used to have some kinds of Sumerian cuneiform clay tablets. So this is the technology, in olden days, like before 3,100 years ago. This is the uh, tool they used to have to record and store this economic information. Okay, these tablets contain some valuable data and information such as distribution and deliverables of grains like barley and wheat. And later on, the civilization, improved, and these back to 1750 BC, this complaint tablet to E.A. Nasser. So he started to be a old and known customer complaint. The customer in this case was unhappy with the quality of copper ingots they had received and took their grievance directly to the source. And then this is about the olden days data storage. But coming to that, in the year of 20th century, uh, they used to maintain the data in different tools like databases. That is when I am learning in the year of 1990, I started my career in computers field. Actually, I just started learning COBOL. That is the platform at that time. Then I just used DBase 3 plus. You might not be hearing these words because you are in the current trend. So I wrote my first project on DBase 3 plus. Basically, all those are file-based data storage systems. Okay. Later, they improvised the storage capacity and increased them, and SQL comes into place. That is MySQL and SQL Server by different vendors and different companies. Okay. And coming to the data, where the data engineering. What is data engineering? Bill Inman is the founder of this data warehousing concepts. In his 1993 book, Building the Data Warehouse, he defined this system, this data engineering, as the construction of a system that converts data into information. See, data can be in the form of scattered data. There is no meaning before converting that data into information. So to have that information, like a meaningful information, we need to convert that raw data. So the conversion process is the role of this data engineering task. Okay, and really this data engineering started late 20th century with the rise of big data and distributed data architectures. Big data, why big data? Because people are storing the data, in every second. When you open any social media platforms like Twitter or Facebook or WhatsApp or Instagram, they used to enter some information continuously. So that is growing. So that's where this big data comes into place. And to process that distributed data, there is a system called distributed data architecture. Okay, I just need to check whether I recorded this session or not. Yeah, recording is there, no? Right. And this big data is a term that refers to the massive, ever-growing volume of data that organizations are generating. See, not only organizations, as I told you, every human, like when they open their mobile, they used to uh, transfer some data or feed the data. So that has to be stored somewhere. So that somewhere is called the data storage location. Nowadays we call them as a cloud platform. Okay, this data comes from variety of sources, including social media. As I told you, it may be a Facebook or it may be Twitter or X. It's renamed as X, and then Instagram, WhatsApp, different social media platforms, and YouTube. It's a different platform again. That's a media platform. And Internet of Things, IoT devices, data comes from these sources, and sensors and APIs. APIs are nothing but application programming interfaces. Uh, don't worry about them. Those are just some kind of integration packages to get the data from different sources. Okay, that we're going to learn in the future sessions, like using REST APIs or Flask APIs. Okay, or fast APIs by using this Python. Okay, that is very simple concept. APIs are nothing but extracting the data from different online storage devices or storage locations using some protocols. Okay, and data streaming, as I told you, YouTube. That is, continuously many people are posting their videos on YouTube and different media platforms. So that is a data streaming. Okay, and this is about data engineering. Not only this, organizations need to be able to store, process, and analyze this data to extract valuable insights that are used to make better decisions, improve operations, and and drive growth. So why this data is required? To make a better decisions. Okay, suppose when we take this, Amazon or Flipkart, these are the e-commerce platforms or portals. So there you need to go and buy some products. So once you buy a product, in the background, this data will be stored, and the managers or the business people who are behind that, the company, they are going to look into the data or information to take some decisions. So what product is moving fastly and what product is lagging in sales? So they are going to take some decisions based on this data. Okay, and in the early days of data engineering, the focus was on building data warehouses. A data warehouse is nothing but a historical data that contains some large centralized repositories or storing data that could be used for reporting and analysis purpose. See, when you go to uh, any of the marts, like sales business operations, like if you go to some DMart or any other online transaction processing or any other banks, earlier they used to have some databases to store their online data using this Oracle and SQL Server and MySQL. Okay, but as their data is grown and their banks are that these these POS systems are distributed in different locations, so they need to gather that data from different locations, so that they can store the past data, like historical data, previous data, like last year data or previous 5 years data. So that's where this data warehouses comes into picture. Okay, this data warehouse model had some limitations, like it is very expensive to build and maintain, and it is also difficult task to scale up, because whenever the data is growing, we need to increase the size of the storage as well as the processing speed or memory capacity. So to scale up these hardware and software tools, they need to spend some more funds. So that is a very expensive. Another limitation of these data warehouses was they were designed to support reporting and analysis, but not on real-time decision making. As I told you, it just stores the historical data. Okay, and it is not storing any real-time data. So that is one of the challenge or limitation in data warehouses. Okay, and when we come to this distributed data architecture, has many advantages over the centralized data warehouse model. Okay, it is more scalable and easier to maintain. It's also more flexible, as data can be stored in multiple formats and accessed by different users simultaneously. As I told you, this I will show you one second. See, users or customers used to interact with systems like as you are a customer, and when you go to any store, okay, we are going to purchase some items in that store. So this transaction data is going to store in a location. Okay, so that is a database, right? So this transaction, as and when you perform a transaction, directly that data is going to transfer from this location to the storage location. Okay, So this is at that time of instance, like whenever you perform a transaction, immediately the data is going to store in this database. That is called online OLTP. We can call it as online transaction processing. Okay. Okay, fine. So this is the transaction. Whenever you go to any shopping store, or when you go to a bank, so these types of transactions are called online transaction processing or OLTP systems. Okay, but this is in a single location. But the same company or the same bank is located in different locations. So that means they need to store the data in a centralized repository, a centralized database. Okay, so this is one location, right? This is one location. But if you wanted to store the same data from different locations, so they need to have a centralized location server to maintain all this data. And also they need to store not only the today's data, they have to store the past data also. And for that, they implemented this OLAP systems, that is online analytical processing. This is nothing but data warehouse, and this is nothing but database. So here there are different databases, as I told you: MySQL, Oracle, MS SQL, Postgres. Okay, etc. There are so many, but these are the mainly used for this online transaction processing data. And when we come to this OLAP systems, here the data is stored not only the current data, they used to store the last past data also, past years data also. As I told you, these data warehouses are mainly meant for to use uh, to take some decision making purpose, to build some analytical reports, to forecast the upcoming business. So that is the use of this OLAP data warehouses. So we have learned about these two now, OLTP and then OLAP systems. So now, as the data is grown, these two systems are not provided all the necessary tools or the to survive this complete this is about only one format of data, like this is in the form of a tables, structured data. But when we go to this social media platforms, they not only store the text data or some tables data or files data, they are going to feed some images or some music files or some video files. So this is the different formats of data, and this data warehouse and OLTP, these databases are not going to provide such a capability to store such data, such formats of data, different types of data. So that's where our big data comes into picture. Okay, here this data contains or stores not only tables data, it may have different kinds of data like structured data, unstructured data, semi-structured data. Okay, that we'll discuss about these in the next sessions. This is only a brief introduction about data and data engineering. Okay, so to process all these kinds of data, we need to have big data, and not only processing one particular location data. We need to perform different locations data, and we need to have some systems which can be which can do, suppose if we perform this complete processing on this data on this data using a single system, it is not sufficient, right? So we need to have some multiple systems to perform simultaneous requests or simultaneous processing. So for that, this distributed data processing comes into picture. Okay, so here not only a single system, it has multiple systems. Okay, so this is one system. Let us say this is one computer. This is the other computer. This is the computer. Let us say this is one computer, computer one, and this is computer two, and this is computer three. Yeah. Okay. So we need to have. Why it is not multiple systems to perform this distributed data, because this data is not only stored in a single system. The data is stored in multiple systems. So to process all these computers data, we need to have a distributed data processing. So that's where this big data comes into picture, and that is the Hadoop. Hadoop is nothing but a big data platform. That is the first developed system, actually. So, and the processing tools are also different here. Okay, that we will discuss. See here, this is the data warehouse. It may be, see here, there are different platforms I told you. It may be Amazon, or it may be Azure or Google, whatever it may be. The data comes from different sources like Facebook or Salesforce, or some Google Drive, YouTube, Excel data, CSV data. This is different sources of data here. This is data sources here. It may be 250 plus data sources, and the connectors are there to connect this data to the data warehouses. Okay, so this is where your role comes into picture. The data engineer's role is to get this data, process it, and store it in a data warehouse. And again, this data can be used by different people. They may be, they may be data scientists, data analysts, or some decision makers. Our role as a data engineer to get this data from different sources, from different data formats, and store that in a data warehouse. So this is a very crucial role. Why? Because it is a kind of a lab technician. Without a lab technician, the scientist cannot perform or get the right information, a right report. So our job as a data engineer to transfer this data from different sources to data warehouses, and not only transforming, we need to load this and process some some meaningful data. So the main job of this data engineer is to clean that data. See, data may be fed in by human mistakes, may be there, right? So we need to clean that data and we need to process the data, we need to load the data in this data warehouse. So this is a data warehouse. Okay, and this modern data engineering comes into this cloud platform. Cloud-based software architectures are more scalable, reliable, and secure than traditional on-premise data architectures. As we discuss here, this big data is example for tool of this one is Hadoop, right? This is on-premise database. This is only on-prem data. Why? Because at that time they don't have this cloud platform, so they need to store in their premises only. On premises means in their office location only. Okay, so they will be purchasing different computers and then server and connecting these computers to the server. Okay, so there may be a big server here that is connected. So here server, and all these computers are connected to this server. Okay, and all these computers are located, and this server is also located on this office, on their office location. That's why it is called on premises data database. Okay, but whereas here to purchase these many computers on this much capacity server, they need to spend lot of funds. So that's where this cloud platform comes into picture. Okay, with the help of this cloud structure, they are designed for distributed computing. It is a perfect platform for modern data engineering to manage this new distributed data architecture. A new variety of data engineers was needed. So, so the skills to design, build, and maintain increasingly complex data systems. So fortunately, many cloud-based data management platforms now make it easy to collect, process, and analyze data at scale. These platforms are designed to handle big data, and they are becoming increasingly popular with data engineering teams. See, earlier they used to recruit some data scientists. Data scientist has to do all these tasks, data engineering tasks, data analyst job tasks. They don't know how to use that person because at that time there is no that much knowledge how to break this different data in different domains. Again, later on, after improvised their tools and technologies, this data engineering comes into picture. Nowadays, this data engineering is a crucial role, but they are not going to appear to the business people. They are not going to appear to the data, the front end people. Their job is in the back end job, to process, to build, to analyze, means to maintain that data systems. Okay, that is the crucial thing in of the role of this data engineer. And what are the different tasks? So what do these data engineers do? Basically, the data engineers collect the data from different multiple data sources. As I told you, these are the different sources, right? These sources contains the data in different formats, not only table structure, not only a text data. It may contain media data or music data or images data or text data or file system data. These sources are containing different formats of data. Okay, so the data engineers collects these different data from multiple data sources, clean it, process it, and store it in the data repositories for end users. What are the who are the end users here? Data scientists and data analysts. Okay, so that they can use this meaningful data to apply some models or to generate some reports based on this clean data or cleansed data. Okay, and the next task is designing and building data pipelines to collect, process, and store data sets. Okay, and managing administering data storage systems. See, don't worry about these different terms. It is not a complex task, but it is a crucial task. You need to have some kind of learning interest. Okay, then only you will succeed in this data engineering field. But it is very interesting. See, when you go to any programming languages, see, they need to think and analytical, they need to have some analytical capabilities. Here you don't need to have that programming, analytical or complex problem solving uh, tasks. Here just you need to know about the databases and what is the structure and what is that format of data and how to get the data by using our tools and how to store them in a structured way by learning these data modeling concepts and storing them and managing that data in a secured way. So this is a very crucial job. And here the data engineers collaborating with data scientists and other data stakeholders to solve business problems. So data science is the future. Coming to the next 2030, like when you go to this here, these are the job opportunities. With a booming growth rate of 30.7%, the global big data analytics market is projected to be worth of 346.24 billion by 2030, boosting the fortunes of data engineers, business analysts, and data analysts, and data scientists. Very big, very big future is there in the upcoming days for these data engineers. Okay, and the next task is to optimizing these data pipelines and systems for performing efficiency. See, uh, after designing a data pipeline, you need to maintain and you need to look into that particular pipeline whether it is performing the task properly or not, or whether it is having any errors, or whether that pipeline is struck or given some errors. So we need to have that monitoring task also. So that is the task of data engineer. And monitoring data quality and ensuring data integrity. Integrity is nothing but here that should have a meaningful information which is connected with different tables or different formats. Okay, and data quality is also we need to monitor that. And you need to have, as I told you, the the basic and most important required knowledge is the databases, like relation database, like SQL. SQL is required to process all these tasks, and writing documentation and creating diagrams to help others to understand the data architecture. These are the main tasks of data engineers. Okay, and nowadays not only that is not a stopping uh, stopping career here. Again, this data engineer is going to convert into different domains again here: cloud data engineer, big data engineer, streaming data engineer, okay, and data warehouse engineer, machine learning engineer, data engineering manager, consultant or freelancers, okay, data governance specialist. All these are the part of this data engineering tasks only, but the data may be different, but the tasks are same. That's why you need to know about the basics of the foundations of the databases, like what is the architecture of distributed system, and what is the architecture of the processing system of the distributed data processing. Okay, and this is the data engineer's responsibilities. These are the collaborating and delivery and on the cloud infrastructure, and these are used by data scientists and data analysts. Once you store the data properly without any errors, this data can be used by these people, data analysts and data scientists. Okay, these are the main responsibilities of data engineers. And now here, see here, base. When we divide this complete diagram into three different parts, data engineering is a base platform. After the direct customers like business intelligence, engineering, data science, or anyone who can write SQL, business technologies, and on top of this, all the customers like sales, business renewals, risk operations, customer care, tax resolution, finance, insights and operations. These are the front-end customers or the business domains. But base for to do all these operations, this data engineering task is required. Okay, that's why it's a very crucial, and also you have a lot of opportunities in future. Okay, see, one thing is you need to remember: tools may be different, but task is same. Tools may be different, but task is same. When you do a same task in Azure platform, you can do the same task in Amazon Web Services, AWS, but tools are different, but task is same. Or if you go to Google platform, task is same, tool may be different, but you need to have the understanding of that particular concepts, basic concepts. Okay, and as I told you, these are the job opportunities and the salaries according to Glassdoor. The total annual pay of a data engineer earns around this much, including base salary and additional pay like bonuses and profit sharing. The average total pay for a senior data engineer is this, 1,54,989 per year. Okay, and here, this is the blueprint of a data science platform. It is very important. When you understand this diagram, that's enough. We have a connector. This is a source connectivity tools, and we have a storage, and we have a end system, that is a visualization. Connect, store, and visualize. This is the complete architecture or a blueprint of a data science platform. Only these three parts you need to learn. See, also again, this visualization part is different again. This is performed by data analysts and data scientists. Only you need to learn about these concepts: connecting tools, storage tools, and maintaining that particular storage databases. Okay, that we will discuss in the next session. This is the first demo only.